Dear student, here let me start your chapter with the SI units and dimension. Right. In this chapter, we are going to discuss about some physical quantities. Right. Those who have some kinds of units. Is it right? And in this chapter, even we are going to understand about the dimensional formulas. Is it right? Or dimensional equations. What is dimensions? We'll later on discuss. First, let me come to categorize the physical quantity, which we have already done in the class 9. A physical quantity, which is it right, have passed some law already. For example, my name is Vikas, so Vikas cannot be a physical quantity. A physical quantity which is already passed some laws or have some statement, as you know, and these physical quantities are divided into the what scalar and vector. But here physical quantities in the what some units like fundamental and derived unit, and one more is there, and that is the supplemental unit. So first let me discuss about the what this SI units, or better we say units, are divided into the fundamental and derived unit. So what is fundamental? A physical quantity which does not depends on the other physical quantity or are independent are called the fundamental units. Is it right? Some fundamental, there are 7 fundamentals are there. Keep it in mind. You have to learn also mass, length, time, current, amount of substance, temperature, and luminous intensity. Out of this all 7, luminous intensity we rarely used up to class 12, but these all we have to use it. Clear? Mass, what is the name of the unit? It is unit name is kilogram, denoted by kg, whereas in dimensionally we write it is in capital M. As I told, I will discuss later on. Length, meter, m, length, time, second, second t, current intensity, ampere, you know well, a, and symbol with the again dimensionally also a. You can see amount of substance, mole, which we mostly use in chemistry, but in physics also we'll use it in class 11. Mole, mol, temperature, Kelvin, k, and luminous intensity, candela, cd. These are the 7 fundamentals. Is it clear? Now we'll come with the what? So it means very simple. Look at here, mass, length, time, current, they are not depends on others. For example, the velocity. Velocity is equal to what? Distance by time. This is a formula where velocity depends upon the distance and time, but distance is never depends on other. So what happened here? Distance is a fundamental, time is a fundamental, but velocity is derived. This is the difference. Clear? Okay. Now let me discuss about the derived unit. As I told you, any physical quantities which depends on the fundamental units, yes, or they are derived or taken from the fundamental are known as the derived units. Is it right? So derived unit is, for example, as I told you, velocity. Velocity is equal to distance by time. So distance is fundamental, time is also fundamental. So the velocity is taken from both the fundamentals. Is it right? Similarly, speed, acceleration, force, etc. These all will come. Is it right? Except the 7 and this 2. 2 angle and solid angles are known as supplementary units. You know, their dimensions are not formed. Keep it in mind, their dimensions are not formed. That's why we never take its unit. Is it right? We never write its unit, or the unit is not included to form the formula. I think you will confuse with that, so we'll discuss later on when we'll discuss about the dimension. देखेंगे यहाँ पे. Is it right? Whenever we form any dimensions, so keep it in mind. जैसे we know well that any equation like F force equal to mass into acceleration. So the force, whatever the dimension has force, it is equal to the dimension of mass and acceleration. They are equal. Is it right? Similarly, if there is any angle, so we will not include in the dimensions. Keep it in mind. There are so many examples, will come later on discuss, right? So unit of the angle is radian and solid angle is steradian. Always we keep in mind, radians we short form we write RAD, is it right? Stay radian is STE, is it right? Stay radian, we simply write, where stay radian is also very rarely we use radian, we use it, right? We will discuss later on radian ka bhi bahut kuch hai. So this is about the derived and the what supplementary units, whereas definitely there is a dimension form of all the derived units. Is it clear? Okay. Now about the units, so there are some system like what happened here. System, suppose I am a scientist and my friend which is in the UK and France, we all are discussed with each other related with some instrument or related with some devices or the readings. So whenever we share with each other, we always follow the international system of the units. Maybe I can share with CGS, MKS or FPS. So what is the full form of this? There are 4 different system of units are there. CGS centimeter, G for gram, S for second, M here it is meter, K for kilogram, S for second, F for foot, P for pound and S for second. FPS, is it right? Where this SI is the international systems, means we can discuss in the, and this international system is actually in the form of what? MKS forms. Means if I'll ask you what is here meter, if it is length, then length measured in the meter, because as I told this is in the form of what? Meter, kilogram and second. So international system of units always follow the MKS systems. Even your teacher also sometimes asks you the question that please write the answer in MKS or SI unit. So SI means actually the internationally accepted the units, then that is what MKS. Where CGS and FPS is also there, but you know the student even rarely they write in the FPS and CGS. CGS we write, is it right? Okay, so these are the system of units in which we are going to discuss, is it right? And now this system of units which I have already written this, suppose question is given, right? Example, suppose I got 10 what? Suppose 10 centimeter per second. So centimeter per second if I write, that means I have written in the CGS. The teacher may ask please find out in meter per second. That means you are going to convert to what? MKS. So the conversion also we can write it. Whereas we also can find, is it right? This is 10 divided by what? Meter. So it is divided by 100. Seconds are definitely we can cancel it also. So overall it is 10 to the power minus 1 meter per second. This is a simple way to convert it also, or there is one more way is there, and that is called the with the help of dimensional analysis. So we'll do, is it right, later on. So the measurement of the length, why we use this measurement, right? You know that to find out the distance or the length, is it right? For small length we always use the measuring scale, is it right? For the large, very large, is it right? Large length, we use the parallax method. So now come to the point of what is parallax, is it right? Suppose this is the surface of your earth. I think you can see this is the surface of earth. You know? Like this. This is the surface of earth, and here this is Siliguri and D for the Delhi, suppose, is it right? And this is a star, right? So whenever we measure any star from the large distance, we, what happens? Suppose you are in Siliguri, you are observing a star, and you observe like this, you know, and your friend which is in Delhi, he is also observing the star like this. That means both are parallel, but the distance between you and the friend is very large, but still they are parallel. So it means very simple. From the surface, this is a surface, you are observing straight. That means formation of a 90-degree. Why it is 90? Because of star is very much far away. Is it right? It is too far. So that means this part, wherever you stand here, suppose you are in Siliguri, that means this is the part of 90. So if it is 90, and let me take this is x and this is also x, and this is what distance. What to take this is, let me take this is x already I have taken. So this is t, is a distance. Let me write here SP, and this is D for distance. And I think it's good. Clear? So if it is x and x and this is D, so now this is a part of 90. So if I will take this 90 degree, this is, you say it is D, this is what, x, and this is also x, this is what, 90. So if I will take tan theta is equal to perpendicular, is it right? Perpendicular, then I think this is a base, right? So this is perpendicular by base, which is x by d. But when the angle is, this is theta, right? Which is theta? Definitely this is theta. Theta is the angle between the two inclinations. Clear? So keep it in mind, as I told you, suppose you both are observing parallel. Parallel means theta is 0, but the star is not too much far away, is it right? So let me make a small angle, that means 1 degree up to 1 to 2 degree, not more than 2. That is called a small angle. So up to 1 degree or 2 degree, you can see that there is an angle formed. So if the angle is very, very small, so keep it in mind, here I will write, if theta is very small, then tan theta is equivalent to theta. Even let me write, this is also sin theta को भी equivalent to theta लिखते हैं. So this becomes theta and this is x and d. So you know how to write its unit. इसका unit कैसे लिखेंगे? Its unit is right in radian. Keep it in mind. Is it right? Always we write in the radian. So ये हो गया तुम्हारा parallax का formula. Very simple, right? This is x, this is d, this is theta. Theta is a far away object. Keep it in mind. वो रखना. बाकी base में 90 रखने से तुमको समझ में आएगा who is perpendicular and who is base. Now student, listen here. How we are going to convert to degree to radian or radian to degree? Keep it in mind. Degree to radian. So this is 90 degree. Write down here the 90 and multiply with pi by 180. Yes, pi by 180, you will get pi by 2. 60 degree conversion. 60 into again pi by 180, pi by 3. Similarly, if I am going to convert radian to degree, how to this? Suppose pi by 2 I will take. Pi by 2, यहाँ पे तुमने pi by 180 किया था, यहाँ पे 180 by pi करना है. Is it right? You will get 90. Pi by 3, you will get 60. Do it. Is it right? And if you have any problem, then you can send it in the WhatsApp. Is it right? Now, in the similarly, you have to learn this 3 radians value is very important, right? Which are the 3 radians value? You know well, ki in 1 degree is there, right? There are 60 degrees, is it right? So in 1 degree there are 60 minutes, and in 1 minute there are 60 seconds. Once again, 1 degree there are 60 minutes, and in 1 minute there are 60 seconds. How we write this? Dash means minute, double dash means second. 90 degree, if it is pi by 2, then make it 1 degree, so divided by 90 kar lo. Then you will get this value. So keep it in mind, 1.744 into 10 to the minus 2 is the radian of 1 degree value. And since 1 degree is 60 minutes, so let me divide again with the 60 to get 1 minute. So it will give you 2.91 into 10 to the minus 4 radian. Again 1 minute has 60 seconds, so again divided by 60 to get you what second? 4.48 into 10 to the minus 6 radian. It will help you in numerical. Is it right? Yes. It's very important. Thank you. Again I will take you the another video. Thank you.